Hey everyone, I'm Nancy Gibson, a contracted environmental technician with the USDA Southeast Climate Hub, and I will be talking to you about our salinization manual titled Identification, Mitigation, and Adaptation to Salinization on Working Lands in the US Southeast. Working lands, which I will mention during this video, includes farms, forests, and ranches. The objective of this presentation is to familiarize you with the salinization manual we have developed to assist producers with management of lands when dealing with the current and changing impacts of salinization. The manual is available on our website, so to find it, just search for the Southeast Climate Hub, click on our page, and it is featured on the main page. Sea level rise is accelerating in the Southeast. For example, the sea level around Wilmington, North Carolina has risen by 11 inches since 1950, as you can see on this graph, with years on the x-axis and sea level change in inches on the y-axis. In this location, the sea level is now rising by over 1 inch every 2 years. Both sea level rise and hurricanes will continue to respond to climate change and cause productivity losses in forests. Some storm surges can contribute to soil salinization when they bring salt water with them to coastal forests. And sea level rise also contributes to these type of storm surges and salinization. Salinization is a growing threat in the Southeast, with increasing ghost forests, marsh migration, and land transition to salt marsh being reported and studied. While salinization from sea level rise is slow and happens over a long period of time, a salinization event due to a hurricane occurs suddenly. To help producers understand and identify coastal salinization and how to manage for resilience, we developed the Soil Salinization Adaptation Manual. Soil salinization in the coastal southeastern United States is becoming more prevalent as storm surges increase in frequency and sea levels rise. Salinization reduces the productivity of working lands and can prevent crops and trees from growing. This manual describes the impacts of salinization and includes adaptation measures that can be taken to maintain productivity in working lands. The first 2 chapters of the salinization manual describe the background information and how to assess and minimize salinity risk. The background chapter includes information on the processes of salinization, testing soil for salinity levels, and other descriptive information. The salinization manual frames soil salinization as stages, ranging from 0 to 5. Stage 0 is non-impacted land, and stage 5 is the point where sea level rise has converted the land to chronic surface water. As you can imagine, the productivity of working lands decreases as soil salinity increases. The manual includes a description of each stage and what productivity limitations to expect in the stage, along with mitigation and adaptation measures that are appropriate for the given stage. Soil salinity is measured as electrical conductivity using the conductivity of a saturated soil paste extract. Each stage in the manual is assigned a range of conductivity values, and they increase as the stages progress. So one way to determine which stage you are in is to test the salinity of the soil. Stage 0 is non-impacted land. Baseline site characteristics such as productivity are established at stage 0. At this stage, forest and crop productivity is not yet impacted by salinity. However, the soil may be at risk of experiencing salinization due to proximity to a saltwater source. Stage 1 has low levels of salinity and forest stands are likely to recover. Some seedling growth may be unaffected at these low levels of salinity. Crops that are sensitive to soil salinity will experience productivity decreases. Mitigation efforts are only possible in stage 1, and conservation practice standards can be used for adaptation. Saltwater intrusion is expected to impact a growing extent in the Southeast, leading to the possibility of recurring salinization events. In stage 1, the conductivity or soil salinity ranges from 2 to 4 decisiemens per meter. We have included a table of common crops and their estimated percent yield due to these salinity levels. It is important to note that these calculations for percent yield take into account the impact of salinity stress alone and may not be representative of a crop under stress from multiple sources. Stage 2 involves moderate levels of salinity as it builds up in the instance of salinity events occurring at a rate that is faster than soil recovery. Forests may begin to show signs of salinity stress, but can still be economically profitable. Site recovery depends on local hydrology and elevation, though sea level rise will continue to bring saltwater inland, leading to chronic salinization. Stage 2 salinity ranges from 4 to 8 decisiemens per meter. There are 14 crops still able to produce 100% relative yield at 4 decisiemens per meter, though only 11 produce over 70% relative yields at 8 decisiemens per meter. Stage 3 land is strongly saline, and forest stands show severe signs of salinity stress. At this stage, it is recommended to begin thinking about converting the land into non-forest salt-tolerant crops or non-commercial land. Stage 3 salinity ranges from 4 to 8 decisiemens per meter in electrical conductivity. And when soils reach 8 decisiemens per meter, commercial forestry is no longer profitable. Alternative crops, such as seashore mallow and salt meadow cordgrass, are discussed in the manual as adaptive options, although the markets for these alternative crops are not always reliable. Although stage 3 has a limited number of crops with a high tolerance for salinity, there are still options that remain viable if salinity is the only stressor. Even at 16 decisiemens per meter, crops such as barley, asparagus, and quinoa may produce over 70% yield. The manual ends with stage 4 and 5, which I combined on this slide since working land productivity is low in these stages. Tree mortality will lead to salt-tolerant vegetation such as cattail, common reed, and sawgrass moving into the open spaces left by dead trees. Freshwater tree seedlings are unlikely to grow in this more saline environment. However, the salt marsh does have environmental benefits that are also described in the stage 5 chapter, although the land is no longer able to be worked as commercial land. The NRCS has identified salt-tolerant herbaceous plants and their upper pH limits to be used in conservation easements. We have included information on plant species, varieties, cool season grasses, legumes, and forbs that may be helpful for lands transitioning to conservation easements as they are removed from commercial productivity. The appendices of the manual also has many useful tools and resources, including numerous conservation and farm bill programs that may be of use to the landowner. I hope you found this video to be useful and informative. If you like, you can download our salinization manual and other resources from our website today at climatehubs.usda.gov/hubs/southeast.